welcome to the Quantified Health, Wellness and Aging podcast, a podcast about the latest products and services, technologies and people pushing forward a new frontier. Bimonthly S Dryburgh hosts a pioneer for an in-depth discussion. And now over to the show.
Hello and welcome to episode number 19 with Stephen J. Matlin. He is a CEO and founding shareholder of LifeLength. He has led the company since inception and established it as the world's leading telomere measurement diagnostics laboratory and Spain's most highly accredited lab. He was previously the founder and managing partner of corporate finance and strategy consultancy firm Matlin Associates, which acted as an advisor in all the work prior to creation of LifeLength and on behalf of other stakeholders. The Matlin Foundation, Spain's largest private foundation, and Dr. Marie Blasco, a recognized world expert in telomere biology and director of the Spanish National Cancer Research Center. Stephen graduated from Harvard Business School, where he obtained his MBA with honors and holds an undergraduate degree cum laude with honors from Dartmouth College. Hello and welcome to the show, Steve.
Good morning. Thanks for having me on.
It's a pleasure. I have wanted you on for quite some time. I came across LifeLength a number of years ago. I don't know if you can remember how I came to you all those years ago. It was from a functional medicine practitioner in the US. Do you have any recall?
To be very honest, I don't remember how we initially got in touch.
Yeah, I think it was, I don't know, the name was something like IDX or something of this nature. But I remember that some good functional medicine practitioners advocated for using LifeLength. And I remember thinking, that's odd. They seem to be shipping blood samples back to Madrid in Spain, which seemed quite unusual. And maybe I'm jumping off way in the deep end here. Is that still what takes place today? That if these functional medicine doctors take a LifeLength sample for their clients, or we should call them patients, are they still getting shipped back to Madrid?
They are. Yeah, we are. We're a send-out lab, if you will. So all of our clients, whether they're in Los Angeles or in Tokyo, their samples make their way to our facilities, our U.S. federal, Spanish accredited laboratories here in Madrid, where we analyze them. We've put into place, obviously, a very sophisticated and robust logistical system so that we're able to get samples from virtually anywhere in the world, to our laboratories here in Madrid, perform the telomere analysis on them, generate the report in the language of the patient or doctor, depending on where they are, and deliver that back to them electronically.
If you could be so kind for the sake of listeners, could you give some kind of introduction to telomere biology, maybe mention Hayflick limits, senescent cells, apoptosis, and just begin there if possible.
Sure, of course. So telomere biology is actually a field of science and research that goes back all the way to 1938, when the first publication came out that theorized or hypothesized that there must be a cellular mechanism that regulates the aging process. At that time, of course, there was no tools to actually see telomeres. We didn't have the microscopes. We didn't have the ability to see them. It was a little bit like theoretical physics. But then over the decades, investigators and researchers continued to look at the mechanisms by which cells divide. And as you mentioned, Leonard Hayflick was crucial in this path because he demonstrated that cells have a finite capacity to divide. And he established something that is known as the Hayflick limit. And what the Hayflick limit refers to is at the ends of our chromosomes, inside every strand of DNA in our cells, there are these protective caps, which are known as telomeres. And the telomeres, what they do is they don't encode for DNA or gene expression, but rather they serve as kind of the aglet or the plastic tip at the end of the shoelace that keeps the DNA from unraveling in the process of replication. And every time our cells divide, we have many hundreds of types of cells in our bodies, and the rhythms of division vary both by the biology of the cell type, um, lifestyle factors, genetic factors, many other things that influence in this. These telomeres are whittled away due to a very complex genetic process called the 3 to 5 end replication problem, which makes it very difficult to copy the very edge of the trailing strand of DNA. So as we age, these telomeres get shorter and shorter, and we begin to have, as you said, senescent cells. And senescent cells is nothing more than a fancy scientific term for cells that are there, present in our body, but aren't really contributing anything to our health. They're unable to further divide. They're unable to reproduce. They're just kind of dead weight. And the process beyond senescent cells becomes apoptotic cells, where cells are just in the state of apoptosis, where they're basically dead, and those cells we'd like to clear out. And one of the clearest examples of how telomere biology works in practice is if you think about what it's like when you were 7 years old or 14 years old and you fell down on a skateboard or a roller skate or whatever, and you scraped your knee, and how within a day, 2 days, 3 days maximum, that tissue just almost magically healed. Just overnight, it was pink and healthy, and then within a couple of days, it was like you never had any accident. If you do if that same thing happens to you when you're 40 or 50, the most likely for most of us, we're going to heal equally, but it's not going to happen in 2 or 3 days. Maybe it's going to take a week. Maybe it's going to take 10 days. And that's because in the tissue that's been damaged, there's now a percentage of cells which are senescent. So those cells are unable to reproduce. They're unable to generate new daughter cells because they've reached this Hayflick limit where their telomeres are now too short to continue to divide. And they've sent a message saying, hey, we can't continue dividing because if we do so, we actually may have errors in the replication process. And that actually is a risk for cancer. So telomeres have a role to protect us from cancer. And then if we move forward to people who are in their 80s, 90s, or beyond, people who are really elderly, one of the most common causes for those people getting infections or even dying is they'll get a wound, they'll get a cut, they'll get a bruise, and it won't heal. And it won't heal because they have no cells that have proliferative capacity left. All the cells that they have, all those telomeres have been used up. They have all senescent cells, and they're not able to regenerate new tissue. And that example of the skin is occurring in every single organ and component of our body. So that's a little bit of background about sort of basic telomere biology and why understanding telomere length and how telomere length influences cellular health is really important.
Could you mention the heart and endothelial function, maybe, just to bring in that angle? And telomeres as in cardiovascular disease angle.
Sure. I mean, the BMJ, the British Medical Journal, published an article on the cover of the magazine at the time about a meta-study that had to do with telomeres and the risk of cardiovascular disease. And it was a very interesting article because what it said was telomere length is an independent risk factor for cardiovascular disease. So you have the famous Framingham score and many ways to assess cardiovascular risk. But people who have shorter telomeres generally are at greater risk for developing cardiovascular disease, even with, say, similar levels of cholesterol or lipids. And that goes back to our analogy. It makes sense. If you have better telomeres, you have perhaps less senescent cells, your endothelial function is going to be better. So even if you have the same diet and you're eating, let's say, the same amount of saturated fats, that fat won't find a place to adhere inside the walls of your arteries because the surface is too slick, it's too smooth. But if you have poorer telomere function and less and more greater senescent cells, then you're at more risk of developing heart disease. So it was really a very interesting publication and shows again why I think telomere biology and telomere measurement is in fact a clinically useful test to perform.
So telomere length associates with, I think, all age-related diseases. You would agree with that?
Telomeres, I think, are related to almost all age-related diseases. Correct. There's diseases where there's a clear relationship or where they play perhaps a more substantive role. And there's others where it's not exactly clear what level of contribution they make. But for example, in the field of oncology, there's something like 10,000 publications on the roles of telomeres in cancer development. So yes, I would agree that telomeres play a contributing factor to virtually all age-related diseases.
And telomere attrition is one of the 9 hallmarks of aging.
It is, and in fact, in that publication that you were making reference to, it was a direct cause, but it is also an indirect cause, I believe, of 3 of the other factors. So telomere attrition also obviously, I think, other factors including cellular senescence and methylation and mitochondrial function. I don't have that table in front of me, but if you looked at it, I think there were 3.
Like genomic instability.
Yeah. So I think something like 4 of the 9 factors, whether directly or indirectly related to telomeres. So, I think people who talk about telomere biology, there's obviously different views, and there's no black or white answer, as we were saying a little bit before the call. But I think it's pretty indisputable that telomeres do play a material role in the aging process, because as we erode our telomeres, that is driving us inevitably towards aging, which is essentially the mother of all diseases.
When I came across yourselves all those years ago, I had came to understand that if I measure with, I'm trying to think of a way of putting it politely. I'll just name a company. If I measure with the likes of Telo years, I came to understand that was I would describe it as relatively a pointless test. But I was led to believe by a great functional medicine practitioner back then that life length is a great health biomarker, and it gives you not just the average that you have length, but it tells you the number of percentage of critically short telomeres, and this is a robust health biomarker. Could you help introduce that concept and differentiate yourself from much cheaper telomere tests, which I actually don't think have much point? But if you think they have a point, please let me know. I'm not aware of one, and I find it quite odd that Teloyears actually sell supplements also as part of the subscription and try and get you into a buying cycle. And I just cannot see how their test is a good enough measurement of an intervention, even if it's a great intervention. So can we open up that topic?
So as you said, we're not rallying against Teloyears or anything, but what we're looking at, the question is, what is the fundamental utility of biological measurement that we're making? So in the case of Teloyears or a few other companies that are out there that do this, that what they measure is using a quantitative PCR. And what that provides is an average telomere length, all of the cells in a sample. And it turns out that average telomere length actually doesn't really mean anything. It's sort of like my father used to have an expression where he said, if you said that on average, you had one hand in the freezer and one in the frying pan, you could claim that on average you're comfortable. Well, actually, that obviously is pretty clear that wouldn't be the case. The challenge we face in telomere biology is that telomeres are very heterogeneous in length, not only in the different types of cells in our body, but within the same set of cells, within the actual nuclei of the cell, you have 23 pairs of chromosomes, and each one of those chromosomes can have a different telomere. And what the cells are being driven by, what determines the senescent process, is not the average telomere length of those 92 telomeres across the 46 chromosomes in the cell, but the shortest telomeres. So the analogy I was trying to give was what matters to us biologically, and what we try to provide in our assessment, is the percent of what we believe are the shortest telomeres. Now, And you can't do that with an average measurement. So from our perspective, because we start at the most granular level, at the individual chromosomal level, we have the ability to give all the information. So we give the average telomere length, of course, but we can also look at not only the average telomere length, but the median telomere length. Another factor that's very important is what we refer to in the lab industry is the CV, or the coefficient of variation or variability. And that is, if you run the same sample multiple times, you get the same result. And the answer that most people might not be aware of is in a laboratory test is that you almost never get the same exact result. In any kind of lab test that is measuring, that is not binary. So if we're not talking about a pregnancy test, we're talking about cholesterol measurement, for example. If you take the same blood sample and you run it 3 times, you will not get the same cholesterol value. It'll be close. Should be very close, typically within 2-3%. But there can be some variability in the blood samples of the actual sample itself, and there's some variability in the equipment. And so you can have small differences. And you want to obviously minimize that difference because what you want is that your test is as accurate as possible, and you're minimizing the interference and the error introduced by the process or the machines that are being used. Our assay has a CV, we estimate, of below 5%. So when we measure telomeres and we repeat the samples, we should always be within 5% of that initial measurement. We'd like to be even lower. In fact, we're working now, we've recently acquired last year a new microscope, a much more sensitive instrument, that we hope is going to lower that coefficient of variation down to the 1 or 2% threshold. And that really matters because when you want to then look at telomeres over time and as a factor of biological age and how are we aging, 5% actually can be quite a lot. If we think about people having an average telomere length, say, of 10 kilobase pairs, 5% would be half a kilobase. So a 5% error would mean you could be within 9.5 to 10.5 kilobase would be a lab result with a 5% range of error. But the difference between biological age in our database between somebody between 9.5 kilobases and 10.5 kilobases is actually a few biological years. So it's really important that we try to minimize this CV so that when people do linearly testing, which we think that testing serially is very important as well, because like any biomarker of aging, doing it once is really not that useful. Because the first time you do a test, you kind of just see how you are compared to some kind of data set or database or some reference range. But if you really want to see how you're aging, and this could be cholesterol even, you want to look at it over time. No doctor, no physician would ever say, hey, you've done your cholesterol is 180, full cholesterol, LDL, HDL, blah, 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 we're done. That's not how it works. The doctor's going to say, good, Lee, you've got good, cholesterol levels are good, maybe we can get them a little bit better. Let's retest in 6 months, let's retest in a year. And the same goes for telomeres or any other biomarker of aging. So when we come back again, finally, to the PCR test, the test that's performed by other laboratories, which we also do. We can do that test in our laboratory, and we do it sometimes when it's necessary. The coefficients of variations of those types of tests tend to be upwards of 10, 15, even sometimes even high as 20%. So that really begins to get to a level where you have really no good visibility on what the real value is, the true biological value. If we did cholesterol testing for a patient in our lab, and we told that patient that their whole cholesterol was 200, and then we reran the sample, and the second result was 230, and the third result was 170, which is a 15% coefficient of variation. So we had a resulting range in the same sample of 170 to 230. That would mean the difference between possibly prescribing statins for high cholesterol to probably saying, yeah, you've got actually quite good cholesterol levels. So that, from a physician's perspective and from the patient's perspective, is a level of variation that makes the test essentially useless. So we have worked very hard to get our CVs down as low as we can and continue to strive to get them lower so that we actually do have clinical information and we eliminate the variability that is introduced by the actual process of measuring what are very tiny objects. But telomeres are measured in, if you convert telomeres from kilobases to meters, you're talking about nanometers in length. So very, very small objects and obviously very difficult to measure with this level of precision.
So I'm interested in generally in not dying, but I think a larger interest is whilst I'm alive, staying healthy, because being unhealthy can be like being not alive and not dead. It's a sort of limbo land, and it's not a region I wish to inhabit if I can avoid it. And so years ago, I figured that the blood sugar was, out of control, and I fixed that. I got below what we'll call a personal fat threshold. Also got the fat out of the liver. In other words, cured diabetes. I'll say reversed. And then it was the next risk factor I figured I'm always looking for the weakest link is it was cardiovascular. I fixed that, perfect lipid profiles. And then I remember I wanted to check number of critically short telomeres. So I came to yourselves, I measured, and I don't think it was a good score. And so then I took an intervention. I took a telomerase inducer, which I think we should talk about. For listeners, it was TA65, invented by Bill Andrews, who many will have heard of, although I think he would advocate for not taking that one and taking TAM818 instead. I just wanted to begin with the TA65 and see what happens. I took it for a year. And yes, the number of critically short did grow. And actually, I think the TA65 acts best on the number of critically short. And so, I would say that intervention appeared to be a success. I only tested 1 year apart, but the length grew. And so, could you say what happens once those number of critically short telomeres? What happens once those caps are gone, so that people have an understanding of why critically short telomeres are an issue? What happens once that fuse is finally gone, typically?
Absolutely. So as we mentioned a little bit earlier in our discussion, we're each born with unique telomere length, just like we're born with unique set of DNA and genes. And the telomere length that we're born with is obviously impacted primarily initially by our genetic inheritance as our parents, and predecessors, grandparents, and so on. And then as we grow up, telomere length responds to different pressures. One is the genetic evolution of our being, and the others have to do with environment and lifestyle factors. And cells, as Dr. Andrews can speak to, their cells have a finite. All cells have a finite lifespan. This was established by Dr. Hayflick now more than half a century ago. And certain cells, like blood cells, white blood cells, red blood cells, will turn over continuously. You'll turn over all the cells in your blood within a space of a few weeks. Other cells in your skin or your organs will turn over more slowly. And some cells, like neurons in the brain, will turn over seldom or almost or never. So we need to protect all of these cells as best we can, because every time the cells turn over or divide, we're going to use up our telomeres. So anything that moves away from an ideal health span or lifestyle is going to accelerate that telomere attrition. It's going to drive further cellular division. So inflammation, diabetes, smoking, poor diet, sedentary lifestyle, excessive stress, thousands of other factors that we could easily name and which virtually every one of us has some of them, is going to cause us to have telomere attrition, which is moving away from the basal or minimal level that we would have if we had a perfect lifestyle. If we were a monk living in the less stress-free place on the planet and the cleanest possible air with the cleanest possible food and water and the best diet, that would be kind of the basal level of telomere length. And that the lifespan of human beings controlled or regulated by telomere length has been estimated repeatedly by many studies, many scientists, to be around 125 years. And as we know, there's, I think, the oldest person on record, I believe, was a Dutch woman, reached something like 123 years, and only maybe a very few people have ever documented reaching 120 years. But obviously, more and more people are reaching 100 years now, and that number is increasing. So, what we would like to do to maintain our longest potential lifespan, but more importantly, as you said, health span, which I think for most people, more than most normal people, more than saying, the person who's going to live to 1,000 years has already been born and so forth. Some of the kinds of comments that people have made about the future, which is very difficult for us to see, is rather how do we reach into our 60s, 70s, 80s with the greatest possible level of physical and mental autonomy, and with the kind of energy and, if you will, biological age of somebody decades younger. And that's where our telomere biology is very important, because, as we've said, telomeres are one of the key factors in the hallmarks of aging and contribute substantially to many other of these processes of cellular health. So by protecting our telomeres, we're protecting not only our longevity, but our health span. And the interventions, if you want to talk about interventions, that we make, the most important interventions are in a sense banal, in the sense everybody sort of knows what we ought to do and what we should do, but actually virtually nobody really does. And that has to do with being very disciplined and having a very healthy diet and in not having a sedentary lifestyle, which I always say doesn't equate necessarily to going to the gym 3 hours a day. There are a lot of people who say, I just cannot stand the gym is the most boring thing in the world for me, or whatever. Being being a gym rat and being sedentary, you're not opposite ends. You can have an active lifestyle because you go cycling, or you go jogging, or you walk your dog, or you do calisthenics, or you do any other activity. There's lots of activities you can do that don't involve necessarily having to go into a gym. Obviously, in my particular view, I think strength training, aerobic training, and stretching are the three components of really taking care of your body. And I think you need to make sure you have those three factors, but it doesn't necessarily have to be done in a gym. Anyways, if we address these kind of factors that we all know, then we move on to the realm of supplements, as you described. And I think from my own personal experience, and now more than a decade being a strong believer in taking supplements, I think the supplements have a very important role in supporting our telomeres and our overall biological function. And most people, almost all of us, need them. I'm going to pause, and if you want, we can continue to discuss more details about this aspect of things.
Yeah, I would actually. I find that people will come from a good sentiment. I'm not sure it's the right word. And they will say, oh, we should try and get all our nutrition from food, which I agree with in principle. But I don't think you'll get it at the levels required for longevity. And so, would you be kind enough to share what your supplement stack is?
Sure. I think the question about being able to get everything from our food is very difficult. It would require a level of diet and discipline that I think almost no one has. And unfortunately, I think we also, despite the enormous progress of technology and many other aspects of human civilization, I think the quality of the food that we eat generally today is much worse than what it used to be.
So the vegetables don't contain the same levels of nutrition.
Exactly. And I'm sure you've probably had on the show or you can find somebody who could talk realms about how, the quality of the vitamins and the minerals in tomatoes today have nothing to do with tomatoes of 50 or 100 years ago.
Absolutely true, yes.
And so we have a lot of empty calories. We eat a lot of food. Obviously we eat a lot of processed food, which already we know that we shouldn't eat that much of it. But then even when we go to try to eat healthy foods, we're often, unbeknownst, eating food that doesn't have the same kind of nutritional value that it did. And I think that the quest for and the desire of people to get back to those kinds of food is reflected in the success of companies like Whole Foods that have gone back to saying we're going to source vegetables and fruits and other meats and things in the most organic and ecological way, without pesticides, without antibiotics, without all these things that are in kind of mass-produced food. But of course, that comes at a cost. Not everybody can afford to spend, $9 a pound for heirloom tomatoes. So not the whole world can't eat like that. And part of the function of all the chemicals that we use is we get massive quantities of food. So it's a dilemma, and it's not a black and white thing. And I think it would be unfair to demonize the food industry by saying, well, they're criminals for using pesticides. Well, the fact that we get tomatoes all year round and tomatoes are so affordable, or lettuce or meat or anything, comes from making these kind of industrial processes. But I think vitamins, therefore, are very important to supplement these nutritional aspects that we are unable to address otherwise. So, my vitamin regime is pretty comprehensive. I'm sure there are people out there who take far more. My basic program is omega-3. I take very high quality omega-3 every day. That's my program. And in terms of anti-aging or telomere biology, I've always been taking TX65. I've always been working. My company has worked with TX65 for forever, I guess now. They did us many years ago. Did a study with us, which I respect a lot, because I think by and large, the people that are out there promoting supplements and vitamins, they kind of play a game, which I think is a little bit unfair, which is they want to have and make claims around the scientific validity and importance of their supplements and health, but then they don't want to back it up with real clinical data a lot of times. And I understand that a lot of these companies are small companies. They're not, giant pharmaceutical companies that can commit to huge trials. But I think if you're going to go out and sell supplements to people, you have an obligation to demonstrate the quality of what you're selling and the biological value of what you're selling. And so TA65 undertook to do a study now, again, many years ago, which they published, where they demonstrated that in a control group of people, 100 people, over a course of a year, in a double-blind study, with people taking placebo doses, a low dose, and a high dose of their product, there was a pretty significant difference in that group of people in telomere length after a one-year trial. And that to me was pretty powerful. Obviously, it doesn't get to the N of one. And that's always very, very challenging. And any physician and any smart person is always going to say, yeah, but how do I know how it affects me individually? And the answer to that is you don't know. You can't know. You can't even know how even the most studied drugs, even drugs pharmaceutical drugs like statins that have been around forever, that have had enormous studies. Doctors will start you on a dosage, and then they'll have to adjust the dosage. Now they'll test and they'll adjust. They'll test, they'll adjust, because some people will be a fast absorber, some will be a slow absorber, some will have other vitamins or other medicines that may interfere, or maybe will have their diet will interfere. So all of that makes the biology of how things like supplements really difficult to determine for an N of 1. So what you have to do is you got to try to get the best supplements you can. You got to do your lab testing. You've got to repeat your lab testing. You've got to adjust your doses, and you've got to see how it works for you. But I think TA65 really did a good job in committing to this study. Dr. Andrews has subsequently been involved with other companies and other products that potentially work.
Well, allegedly TAM818 is more potent, but I don't know if they've done a study.
Not with us. I mean, if I can't speak to all the research or publications that they've done. They've not done a clinical study along the lines of what TA65 or TA Sciences did with my company some years ago. We would love to do that. We would love them to do that, and of course, we'd love anybody who's working in this realm of telomere biology or related to work with us, because one of the services that we provide is in vitro and in vivo studies. And we do a lot of work for pharmaceutical and supplement companies that want to understand how a supplement directly or indirectly will impact on cellular senescence and telomere health. And so, the more evidence you have, the more marketing claims you can make, and the more legitimate your product is, in my view. I mean, so why not do it? If the product truly works, show it. And if you have independent validation from a laboratory like ours, which is the only laboratory headquartered in Spain that's not only, of course, accredited by the Spanish authorities, but by the U.S. federal government. We're a U.S. CLIA lab. So we have the ability to independently validate and show the efficacy of any product. And unlike some other companies like the one you mentioned, we don't sell supplements. We don't promote directly anyone's product. So we are truly independent in the work that we do.
We should have introduced telomerase so we could mention telomerase inducers. Would you be so kind to introduce telomerase?
Sure, that's something that we should have discussed it. So telomerase is an enzyme which has been which was the subject of a Nobel Prize back in almost a decade ago now to
Elizabeth Blackburn,
Carol Greeter, and Jack Jostowski. I don't pronounce his last name very well. It's a Polish name, and I struggle with Polish last names. And those three scientists did seminal work that demonstrated that there's an enzyme which will repair and lengthen telomeres. And the name of that is telomerase. And telomerase is a very important enzyme because it typically exists in only three kind of cellular states. It exists in the embryonic state as babies, as fetuses, because when we are conceived, we or any living creature, in fact, because one of the things that I think reflects the importance of telomere biology that maybe most people don't know is all living creatures have, except for perhaps viruses and bacteria, all living creatures have telomeres. All cells have a finite replicative capacity. And in fact, in mammals, dogs, cats, pigs, cows, horses, the telomere structure is the same of that of human beings. And so the telomere length differs depending on the species, and the rate of telomere attrition differs. And we actually have done work in many different animal species for researchers because we can measure telomeres with our technology. But I think the fact that telomeres are present in all these species takes you back in the biological tree to, I don't know, hundreds of millions or perhaps billions of years, and shows how important telomere is to in fact life, not human life, but life in general. So coming back to telomerase, when we're conceived, we obviously go from an embryo, a single sperm cell, a single ovocyte, to the trillions of cells that comprise a human baby. And that furious process of division, if there was no enzyme to restore the telomere length, the telomeres would exhaust themselves very quickly, and they would reach this half-life limit. And therefore, you wouldn't be able to develop as a fetus into a full-grown baby, or if you did, you would be born old. And in fact, we know that there are some diseases where when the telomerase, the genes for telomerase expression are missing, you are born very aged. These are the two primary diseases are DK, dyskeratosis congenita, and anemia-plastia. These are very rare diseases, but they're well established, and probably people maybe can think about, sort of the Benjamin Button movie with Brad Pitt. And unfortunately, those people don't get born old and get younger. They're born old and get older, and typically by 15 or 20 years, they die from cardiovascular disease. So telomerase is really important in this initial stage of life. And then telomeres are then typically present in two types of cells that are very, very important, both of them for us. One is in stem cells. We haven't talked too much about stem cells, but we all are born with stem cells. And stem cells also relate to this whole issue of proliferative capacity and senescence and apoptosis. So the stem cells that we have in our body are the cells that are able to differentiate and become somatic or very specific cells and are able to reproduce and repair our tissue. So having all the therapies derived from stem cells that we've all read about and all the potential stem cells that's emerging, albeit with all its controversy, people saying it works and others that don't, is based on telomeres. Because those cells, these stem cells, express telomerase, and their ability to reproduce and differentiate and repair and create new tissue, new somatic tissue, is based on the fact that they maintain this ability to express this enzyme, telomerase, and maintain their telomere length. So all the techniques that people are interested in doing stem cells are are predicated on this. And indeed, we've done work for companies that do stem cell interventions. And one of the things they want to look at is, if I take autologous stem cells, if I take mesenchymal stem cells, if I take different kinds of stem cells, whether from your own body or from other sources, and I expand them and I'm going to inject them into you either intravenously, or I'm going to inject them into, say, your knee because you've got a bad knee, and I hope to regenerate the cartilage and the patella or something like this. How effective is that going to be? And one of the things that we believe can be valuable is to look at the telomere length and the level of telomerase activity in these cells pre and post expansion. And so that's actually a service that we offer, because it can be a window into the likely efficacy of the procedure. If you're re-injecting stem cells that you've expanded but no longer maintain any telomerase activity, the chances that they're going to be able to proliferate and differentiate into the specific somatic tissue that you wish to repair is going to probably be pretty low. So telomerase is very important in these stem cells. And the other area of the telomerase is very important is kind of the yin and yang, as Dr. Jerry Shea, one of our advisory board members from the University of Texas, always talks about, is cancer. So cancer cells, many people may know, are cells that become immortal. The so-called famous Henrietta Lacks cells, or HeLa cells, that have been probably the most studied cell ever and been used in thousands or tens of thousands of experiments, are cells that escape this half-life limit. And they escape the half-life limit because what happens in these cells is when the cell becomes cancerous, it is able to upregulate or turn back on these genes that have been silenced in normal somatic tissue that cause the telomeres to just erode, and it begins to express endogenously or on its own telomerase. And it will maintain the telomere length, albeit very short telomeres. They'll be very short because the cells will be dividing very quickly. And that's why cancer, as a general class of disease, is one of the most challenging and most lethal diseases that, if not the most lethal disease that we face as a race, notwithstanding our current situation of COVID-19. And so cancers become immortal because they're able to upregulate this telomerase enzyme. They thereby escape the Hayflick limit, and a tiny tumor with a mutation can go from being something that can't even be detected to, a huge mass inside your brain or your lung or your spleen or your prostate, because of the malignancy enabled by the telomerase enzyme. So you can then say, well, so is telomerase good or is it bad? And the answer, of course, is it's both. It's like in some ways, it's like cholesterol. It's like people say, well, you want to have low cholesterol. Well, you actually can't live without cholesterol. Cholesterol actually serves a very important biological function. Too much of anything is a bad thing, and too little can also be a bad thing. In the case of telomerase, ideally what we'd like to have is telomerase upregulation in our stem cells and in our somatic cells, and presumably the biological efficacy of TA65 and TAM818 and other telomerase inducers is to temporarily induce this upregulation of telomerase in healthy cells. But we don't want to have unexpressed or uncontrolled telomerase expression in cancer cells, because that's going to obviously feed the cancer. So people sometimes will say, well, isn't then taking a telomerase supplement a risk factor for cancer? Let's say I take telomerase inducer and I actually have cancer. I don't even know that I have the cancer, as is most of the time, right? You don't know it at the beginning. It's very difficult to detect. Our view, and I'm speaking of our scientific advisory board and my scientific and medical team, who are the experts not participating in this call, but who supported me all these years, is that's not likely to be the case, because telomerase is expressed endogenously by the cancer cells themselves. So they produce their own gasoline. And the amount of telomerase that they induce is sufficient to keep them alive. But if you expose them to more telomerase, they don't become more malignant. They're not going to grow faster simply because you're taking a telomerase inducer. So in our view, telomerase inducers, which help maintain telomere length, are actually a protective mechanism to ward off cancer. Should you develop cancer, it's not going to exacerbate the thing, because it's the cancer cells themselves that will produce the telomerase. And one of the great potential, but it's never been demonstrated, we're not there yet, and it's been a long time that people have been working on it, would be to develop some class of pharmaceutical drug that actually would inhibit telomerase expression in cancer cells. That would be a very powerful anti-tumoral drug that we would love to have. And there have been companies like Geron Corporation and Janssen and others who have indeed invested a lot of money and a lot of time trying to develop this. And some of them are continuing these efforts, but we're not there yet. There's nothing yet in the market that does that. But that would be something that we hope for in the future will be successful.
So you have these telomerase inducers, which you can are supplements. I'm only aware of the two that I mentioned to you. I think there's a third Bill Andrews invented, or his team, that escapes me. But are you aware of any others outside of those from Bill Andrews?
There are other companies that have telomerase inducers. There's a company in Japan called Defy Time.
Oh yeah, that's actually the third one I've mixed
Yeah.
up with Bill Andrews.
So
So there's only three then.
I think there's a company as well out of Vermont called Da Vinci Sciences.
Oh yeah, but there was a bit of a stir around them that I remember, but I don't know if it was true. There was some slurs, but I never had the time to check if they were true. Do you know anything about them?
I mean, they haven't done, like I said, they haven't done a study with us. To the best of my knowledge, they're a legitimate and serious manufacturer of supplements, and I think they make many supplements. I don't think telomere biology is their main focus. But I think if you go online, you're going to find a lot of companies based on astrologus and things like this.
I think that's what TA65 is based upon, but if I remember, Bill Andrews said, no, it's not as simple as that at all. And
I mean,
he,
I mean, the biology, I'm not the right person to discuss the detailed mechanism of the biology of how the supplements work. Dr. Andrews would be far better than I to get into that. But there are more companies. But because it's so difficult to prove the efficacy for the reasons that we've discussed, and at least in the case of Telomere Sciences or TA Sciences, because their product is quite expensive. It's a tricky thing. For me, it's ironic that we live in a world where there's never been more wealth today than there currently is, and people will spend their wealth in the most, what's the word? Most
frivolous?
Yeah, most frivolous fashions. Fantastic, jewelry and clothing and cars and vacations and private jets and all these things. Really, fundamentally, you get down to the heart of all of this. Whether you're a normal person or you're Jeff Bezos, wealthiest person on the planet, if you don't have your health, if you're not healthy, do you think that Bezos or any of these people would be happy if they had terrible health problems? Look at Steve Jobs.
Even mild health problems. A toothache is enough to destroy your day completely.
Absolutely. So, to me, as an advocate, of course, but as a person as well, I'm prepared to invest in my health, and I don't really get why the medical world and the insurance world won't pay for preventive medicine like supplements or like our testing, which obviously limits very much the amount of activity that we can do because we're a cash pay test, we're a private test. And yet, when I get sick, the cost of treatment are astronomical. And I'm sitting in Europe, but in the United States, the simplest of intervention costs incredible amounts of money. And so much of these interventions could be avoided if we were proactive. And people will invest in the maintenance of their car. Nobody who owns a car, whether it's a cheap car, let alone an expensive car, won't regularly change the oil or won't have the filters changed or won't do those kinds of things. Yet we seem unwilling to make those same kinds of investments in our own personal health. And then when we get sick, we go to the doctor, give me a pill. I want a pill. And it turns out that you can't undo 30 years of terrible lifestyle, like you said, which has destroyed your endothelial function, which has given you type 2 diabetes, because you didn't take care of yourself. So for me, all this whole field of personal investing in your health, like you do, like I do, makes complete sense, because I can have all the money in the world. I can say, do I want to spend more money on another whatever fancy item, or do I want to be healthy? Well, I certainly would prefer to be healthy.
Yeah, I put health as number one, and closely related to that, peace of mind. The two have quite a strong connection. I won't go into, but peace of mind and health is certainly very high on the list. And sometimes you have to make difficult choices to keep them at the top of the list. So I have to mention, in relation to telomerase inducers, I had Liz Parrish on as a guest. As you'll know, she's the first person in the world to do gene therapy on herself. And one of the first two gene therapies she did was the gene HTERT. And I think, as you'll know, it codes for the enzyme telomerase. Do you have any comments to make on gene therapy at all? I don't know if you know Liz Parrish.
I do know Liz. I have met her, and I don't know, unfortunately, the real detail of everything that she's done. From what I just know what I've read, basically. I think the whole field of gene therapy has a huge future with this CRISPR technology, with the ability to edit genes, to remove defective genes, to eliminate things like Down syndrome and other things. That's amazing. It's an amazing emerging world that we're living in. As to the efficacy of what Liz has done, I can't really speak to it because I don't know for myself the results of her work. But of course, if it's effective, it's absolutely fantastic.
So would you say it was the would you like if our telomeres never shortened, period? Do you think that would be efficacious? Or do you see that cells need a timer?
From my knowledge of biology, if we were able to keep our telomeres in essentially a perpetual youthful state, that would be a fabulous accomplishment. I don't see any real value in senescence because it's the pathway towards aging and disease. I mean, so if I think about my own body when I was 18 or 22 and my ability to do exercise and sports and so on, and how I am today, which I'm still fortunately healthy and able to do virtually everything I could do when I was that age, I just don't do it as well. I'm not as fast. I'm not as strong. So from my perspective, absolutely. If we could maintain telomere length, I think that would be fantastic.
I've typed up 40 questions while we've been talking, and I see the time, and there's at least 10 I have to jump through, so I'll speed up here. So people can order directly with Life Length.
Correct.
Yes?
Just
Globally.
Go to our website, lifelength.com. All the information is there. We'll get you set up to get a test. And the direct email is info@lifelength.com. So the website provides everything you need to do to get tested.
Okay, so people can do it directly. I won't ask you for specific pricing, but maybe you could indicate pricing.
No, it's not a problem. I mean, pricing a little bit depends on geography, simply because logistics of moving samples is not a trivial thing. So in the United States, we do typically work through physicians, but if you don't have a physician, we work with doctors like Dr. David Wojnarowski and others, where we can send a kit to you. We can arrange a phlebotomist, go to your home, all of that. And it's around $400. It's not an egregious amount.
And that requires an overnight FedEx ship back to Madrid then?
We work with partner laboratories. In all of the European Union, blood samples come fresh to our facilities because it's feasible and cost effective. In North America, in Mexico, in Japan, in Indonesia, in Turkey, and myriad of other countries where we offer services, we have a local lab, and the samples go to that laboratory, and they freeze them in a very particular way that labs need to move blood samples, and then the samples are shipped to us on dry ice. But that's all invisible to the physician.
And that's included in the price.
It's included. That's all part of it. So if you ordered a kit, if you're in New York or LA or wherever, you're going to get a box that has all the pieces for basically to draw a sample of blood, and there's going to be effectively a FedEx package label to send it to our partner lab, which in this case is in Philadelphia, Pennsylvania. But you don't have.
We work with functional medicine practices, and they offer it to clients who they're trying to prevent getting sick.
Yep. Yeah. We work with all types of physicians, medical professionals.
We didn't actually mention that also in your test you give a biological age score.
We do. We do it, and we do it with, I would say, the most rigor that it can be done with, because this is a very controversial area. So a lot of people say, what does that mean? How do you do that? And what we've done is we've developed a very large database of men and women from 18 to over 85, many thousands or tens of thousands of people. Now I don't remember the exact number. That allows us to determine what is the normal telomere distribution at any age level. And we compare your sample to your specific set of peers, if you will. So if you're a 35-year-old man, your biological age is being derived from comparison to all the 35-year-old men that we have in our database. And on top of that, we don't purport. And I think this responds to people out there who maybe could have said, "Oh, telomeres, it's overrated," or that's not the answer anymore. We've never claimed that telomeres are the only metric for aging, or the only thing that influences in the aging process. What we believe is they are probably the most significant single factor. But of course, there are other factors. Accordingly, when we calculate your biological age, we use an algorithm, and that algorithm assigns a certain weight to the telomere values that come out of our test. And the rest of the algorithm incorporates your chronological age. And so the reason we do that is because we realize that telomeres don't explain the only thing about aging. There are other factors, and we're not measuring methylation. We're not measuring ourselves, at least this time, mitochondrial function. So what we do is we look at chronological age as understanding as the kind of the substitute or the reflection of those other factors that we're not capturing. And what that gives us is results that we believe are credible, in the sense that if you're a 40-year-old person and I were to solely use telomere factors as 100% weight, I could tell you might get a result, and I've seen this with some of the other companies that exist that don't apply this methodology and what I believe is sophistication. You get a result saying you're a 20-year-old biological age. That's just not credible. Nor is it credible to say that you're 60. So by doing this weighted kind of algorithm, where we bind a little bit the results that we give to around a decade or so. So it's very difficult for somebody to get a result from our lab that is either more than 10 years older or younger than they actually are. And I think that provides more stable and more realistic results.
Well, as you know, I've paid for a couple tests so far, and they're not cheap, so I see value in it. How robust do you think the connection is between telomere length and health span is?
Well, I mean, it's a statistical relationship, and I think it's as robust as many other biomarkers that are used in healthcare today. And I'll go back to the one that I think is people that most understand, which is cholesterol. Every single person knows that if you have very poor cholesterol values, you're at greater risk for cardiovascular disease. That's a statistical reality. You take 10,000, 20,000, 100,000 men, women, whatever it is, that have really bad cholesterol and ones that have really good cholesterol, you can predict with a great deal of statistical accuracy the amount of morbidity, mortality, heart attacks, myocardial infarctions that one group will have versus the other over a period of time. And that's indisputable. What you can't do is you can't say, oh, you are going to have a heart attack, in X time frame because of your cholesterol, because you cannot make a prediction of the N of 1. And telomeres have, in my mind, at least a similar level of validity. And that if we have a large number of people with healthy telomeres versus a large number of people who have a lot of short telomeres, there's going to be a much higher frequency of health-related diseases, not only of heart disease, but of cancer and other diseases in the two groups. But we have never purported to say that our result is going to determine your own mortality, because that is just ludicrous. And
I find it to be a great marker for health span, which is why I've been paying for it.
We appreciate that, and we agree with you. And I think it's the same with all these other tests. In lab tests, you can think about two kind of buckets of lab tests. You can think about lab tests that are binary. You're pregnant or not pregnant. You have COVID or you don't have COVID. But then the vast majority of health tests that we do, medical practitioners do, and we kind of as patients do over time, are not binary tests. They're tests of your vitamin A level is X, your cholesterol is Y, your blood pressure is Z. They're not absolutes of yes, you have blood pressure, but no, your blood pressure is 120 over 80. So you have a healthy blood pressure. But how does that evolve over time? And all of these tests that we do to look at health are hopefully tests that you do serially, depending on the nature of the test, with a certain frequency. And we think that telomere measurement clearly is meritorious of being in that group of tests that is done with a certain periodicity. We don't purport or claim or propose that people do it every few months because telomeres move slowly. We discussed earlier in the interview the importance of the coefficient of variation. So there can be some variability in the test, not only because of the sample, but the intrinsic technology that we use to measure the telomere has its limitations. So we propose that people would test annually, or if they're on a very important program of lifestyle change and supplements, perhaps they could retest at 6 months. But we have people who retest every 2 years as well. But we're not.
I wish you offered discounts for people who repeat testing.
We don't. Yeah, we haven't done that because, to be very honest, I mean, there's a lot of cost associated with delivering the service. And we've discussed there's the complexity of getting blood samples moved around the world, and that's not trivial, and it doesn't go down for a second sample, unfortunately.
For your interest, by the way, I just pay €2.50 here locally. Walk in, pay €2.50, they hand me back a test tube of blood, and I send it back to you in a box. So it's super cheap for me and quite quick.
Yeah, well, of course, in Europe, we've tried very, very hard because the logistics are easier to make it more affordable. And our ambition, which I hope will be realized in the not distant future, is to have our own laboratory in the United States. We haven't discussed this, and I'd like to maybe spend a moment to talk about this, if we could, which is the application of our technology in cancer. We've spent almost 3 years now working to validate our test as a tool for improved prognosis, diagnosis, or for treatment decisions in different areas of cancer. And the product or application that we hope to have available commercially in all of Europe with the full European FDA approval in the first quarter of next year, we call it PROSTAV, PROSTAV, which stands for Prostate Telomere Associated Variables. And we've done 2 major clinical studies. We've published the first one in the Nature Group magazine, so people can go online and find it. You can provide. I think I sent you the article. If not, we can send them. You can make them available. And what we demonstrated in these studies is that when you incorporate our specific proprietary telomere measurement technology, we're able to significantly reduce the number of unnecessary biopsies for men who may have prostate cancer. Prostate cancer is the most frequent cancer for men. It'll affect, depending on geography and ethnicity, between 1 in 6 to 1 in 8 men in their lifetime. And while it may not have the highest level of mortality, it's not something that you want to get. It's very unpleasant. And it can really impact your lifestyle in very negative ways. And currently, the standard of care around the world for men, typically from 50 onwards and from 40, if you have any family history, is to do a simple blood test called PSA, which stands for prostate-specific antigen. And the PSA is a test which is supposed to correlate to the risk of having prostate cancer. Problem with PSA is it's actually not a specific test for cancer. It's just a correlation. Your prostate level, your PSA antigens can be high for many reasons. You're an active cyclist, you have an active sex life, you have an enlarged prostate. There are many factors that can influence this. And it turns out that the procedure is when you have an elevated PSA level, which is typically above, it's a scale that starts at nanograms per milliliter of blood. When you're above 3, you're going to be submitted. You're going to do a biopsy. So you move from having a very simple blood test to something that's very, very invasive, very unpleasant, expensive, and actually quite dangerous. Somewhere between 1% to 5% of men who undergo a prostate biopsy will have some form of complication. In some cases, permanent damage to the nerve, which can affect erectile function, urinary function, and so forth. And it turns out that between 2/3 to 80% of the men that undergo a prostate biopsy as a consequence of having a positive or a high PSA test do not actually have prostate cancer. So that's a pretty crappy test, but yet it's this global standard. And
It is definitely a crappy test, and there's awful statistics surrounding it.
Yeah, so a lot of people, and I'm not purporting that we're alone, have tried, a lot of companies have tried to bring better tests that significantly reduce the need to do these biopsies. And we're in the final throes now of the regulatory process to be able to launch our test, which we call, as I say, ProStaff, which will eliminate, we're hoping, as much as 50% of these biopsies without false negatives and false positives.
I think most men die with prostate cancer, as in happen to have it if you test. It's so widespread.
Yeah, I mean, it doesn't necessarily, as you say, it doesn't necessarily kill you. It depends on what's called the Gleason score.
And allegedly, a lot when doctors see it, or if they guesstimate that it won't be your cause of death, they simply don't tell men about it. I do test PSA in the year, so it's only €2, so I just add it to the stack. So I've just got three questions to finish off on.
Yeah.
And so I one here is Bill Andrews said to me that although the study has not been done, there's a good chance that glycans, which Gordon Lauk mentioned, covered, glycans, methylation, and proteomics might be under the control, at least to some extent, of the length of telomeres. Do you have any thoughts on that? And also that glycans and methylation may be a better measure of telomere length. I'm just looking at the relation between those.
Yeah, I mean, I'm not a PhD, so I don't have really a view beyond what Dr. Andrews may have commented on. As I said, we've never pretended that telomere biology explains everything. I'm sure glycans play an important role, and I'm sure there's a relationship between glycans and telomeres. I think my holistic view as an individual, as a CEO, as somebody in the medical field, is the more information you have, the better the decisions you can make, and the more integrative the care that you offer, and the more holistic it is, the better view you're going to have. And I don't see it as either or. You know, I can see both tests that measure all kinds of things being used and being integrated.
Well, I greatly appreciate the time you've given me today, Steve.
It's been a pleasure. Thank you for your keen interest and your knowledge, because it's great to speak with somebody who knows already so much about the field.
I thank you, and I appreciate you in the past for sending me over a lot of information many years ago and getting me started.
Well, we hope we'll continue to be friends and colleagues and partners in this.
For more information, please see hyperwellbeing.com or follow Twitter @hyperwellbeing.